The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, August 8th, 2024. It is the 1-year anniversary of the Lahaina fire. But so we'll dedicate this episode to the victims of the fire and discuss that emergency response and some parallels and lessons learned in the back half. But we'll start off our update today, as usual, talking about Kilauea and the recent earthquakes and ground movement that's happening out there. So that's our intro, Dane. How are you this week?
Yeah, doing pretty good. Kind of quiet on Kilauea. Allow us to focus on the anniversary a little bit more of the Lahaina fire that took place a year ago today. So we'll talk about that a little bit too, huh?
Yes. It's actually been the first quiet week on Kilauea for a while, right? It's been relatively
kind of nice,
busy, something every week.
Right.
So yeah, we'll have a discussion on Kilauea first, then Lahaina. Dane will be collecting questions and leading discussion on chat. So we will have a break partway through, which we can answer Kilauea questions, and then we will talk and just see how it goes on the back half when we talk about Lahaina. A little bit less structured there, but we'll share what we can and see where this takes us. All right, anything else, Dane?
No, I think that's it. Yeah, we'll take some questions and do them in 2 parts, I believe. And first part for volcano related questions, and then if we can answer anything about Lahaina, we're not, super experts. We're just going to go over some reports that document some of it and some summaries.
All right, thanks, Dane. So let me move our screen around and get ready for our summary here. Hello, everyone. This is our Hawaiian Volcano summary for August 8th, 2024. On Kilauea, earthquake rates have remained low following the intrusion from July 22nd to 25th. However, earthquakes are still ongoing in the area of the Upper East Rift Connector, especially, but also to some degree east of Maunaulu near Makaopuhi Crater as well. These are the earthquakes over the last week, plotted by depth. So the yellow ones are a little bit deeper and showing that south flank of Kilauea is also adjusting, moving seaward in response to the magma injection that occurred here in recent weeks, and the adjustment that appears that it continues to propagate through pressure to the edges of that affected zone on either side of this bend of the East Rift zone. So we're calling this the Upper East Rift, and this right here is the Middle East Rift. And those are the areas that are currently showing the most movement. Looking at the tilt meters, at the summit, Uekahuna, we're seeing a fairly steady climb of inflation. And this is the deflation that occurred coincident with that intrusion on that Upper East Rift and Middle East Rift. So since that occurred, we've been recovering and resuming here. It's not just the summit. The GPS signals out in the rift zone are also showing continued uplift and translation, especially to the south, on the south flank there, showing that the situation is still dynamic with magma still moving into that area, and we actually have inflation on both of those sites at present. So pressurizing underground. The situation is still dynamic in Kilauea. The magma is fairly quietly progressing into the Middle East Rift there, causing these ground deformation signals. But otherwise, you'd expect renewed earthquake pulses at some point if pressure refocuses in any particular area. So we'll wait to see what happens next in Kilauea. On Mauna Loa, earthquakes over the past week have been very few at the summit, following the recent pattern. But the tilt meter has shown a slight deviation with a little inflation here that has lagged Kilauea's inflation by a few days. However, most of what we've seen on Mauna Loa as far as these small signals has been adjustments to Kilauea, which is neighboring it to the south and east. So perhaps as Kilauea reinflated, it put pressure back against Mauna Loa and allows Mauna Loa to then show a very small signal that seems to have already flattened out by the time we're looking at it. Overall, the long pattern of Mauna Loa has been one of inflation and refilling following its eruption back in 2022. So we have a little bit more noise scatter the data, perhaps suggesting that there's more wiggle with Kilauea's recent adjustments. But the pattern overall is that of steady spreading north and south across Mauna Loa. And that's our summary for today. Okay, so let's go on to our observations. And we have only a few visuals to share. I thought I'd just share the webcam of the summit, which is looking pretty clear and passive, with some gas coming off and lots of mineral buildup around the crater floor, but similar to what we've seen in many recent months. Maybe a little bit of extra coloration from the deposits as it fills in some of the spots through here. Looking further down the East Rift towards Maunaulu is this lava shield right here. Looking pretty quiet in that direction too. And on Maunaulu itself, looking to the east towards Makaopuhi, you can see a nice landscape view as well. All right, so that is our observations for today. There's not a lot of other stuff happening. Most of the activity is happening underground. So with that said, we'll look at the earthquakes next. And here is our island-wide map of earthquakes plotted by depth. So we have our population of deep Pahala earthquakes still happening slowly. One deep one under Mauna Kea in the last couple of days here. And otherwise, all the action in Kilauea. This is just the last 2 days. If I pull it back to the last 2 weeks, then we'll see a much more populated graph that shows a lot more of the background activity here. And it also comes back into some of the other events this week, such as this magnitude 4 earthquake on the south flank of Mauna Loa at 4.5 miles down. And so that shows you these orange ones are almost always on the flank. The reds and maroons are shallower near the surface. And at first pass, you can somewhat tell, as these colors have been chosen for the depths of different processes on Kilauea and Mauna Loa, that this is actually a flank earthquake. There's another one over there, and here's Kilauea flank earthquakes here in the south as well. So yeah, that's what it looks like over the last 2 weeks. I'll zoom it in for the last 2 days, so you can see that even recently there's been a fairly tight clustering of earthquakes in that upper East Rift connector. The ones by Makaopuhi are still ongoing, have slowed a little bit, and we are still having flank events in response, both shallower and at the regular flank depths right over here. So that's the earthquake pattern, colored by depth. We like to also look at it colored by time. So now we're looking at the last 7 days, and the oranges are the ones that are within the last day. There's nothing in the last hour, which would otherwise show up as red. So let me just flip it back and forth. Here is just the last day and the last 7 days to give you a better idea. And let's do that again, but zoomed into this East Rift area here. So there's 1 day, just the recent activity, and the last 7 days, all of it across the board here. So slowing down, but still ongoing, as you saw from the earthquake count graph. So that's our earthquake review. There's not nearly as many to talk about as some other recent weeks. So we'll move on to our monitoring signals. And we'll start off with the USGS text update from today. We're still getting daily updates, given that Kilauea is at alert level advisory and aviation color code yellow still. And the long and short is there is no eruption. There are still earthquakes ongoing, but no big significant changes in either the summit or the upper to middle East Rift zone. These updates have been fairly similar all week, recapping how many earthquakes beneath the summit, which have been overall quite a lot fewer. Those beneath the upper East Rift, which have increased a good amount, or have increased and stayed elevated a good amount, not nearly the rates as before. And you still have that cluster east of Maunaulu by Makaopuhi, which they're also reporting on. And so 14 events. Some days might have had over 50, so it's down, but still ongoing there. They're also reporting the SO2 emission rate of 64 tons per day, measured on August 7th there. So that's really the most recent information from the USGS. There's not a whole lot of other info in here. We can just restate that the pulses of earthquakes that intruded from July 22nd, 25th had ended. Magma was repressurizing the whole storage system beneath Maunaulu and the South Caldera, and continuing earthquakes and ground formation between Maunaulu and Makaopuhi likely reflect slow accumulation of magma beneath the surface. And so we mentioned last week how we have this relationship between a summit draining and a rift zone filling up, like the possibility that there might be multiple pathways in. And so either we have two pathways feeding both these areas that are both providing magma and filling it up and causing them both to inflate, or we have them separated where one is, and the east rift has just been injected and now redistributing still. But there might be some problems with that. You might have to have a trickle coming in from somewhere. You could have enough going into the whole system that it's inflating the summit, while an extra trickle is still going to the east rift to cause continuing adjustments over there. We'll have to wait for more time to pass to see what the signals say and really discern which of those options is the most likely to be happening. We'll get to the GPS and look at, for example, where we see the ground coming up. But the issue that I have to contend with, I'm looking at the data now, and maybe I'm missing something, is that it looks like hardly anywhere is the ground actually dropping. Right? So it's not like it's dropping in one place and rising somewhere else and clearly moving from A to B. It's not so straightforward as that. So, all right, that's the USGS update. And we will go on to the graphs here. We'll come up to the top and start with the last week on Kilauea, which has been steady inflation. A few little variations, minor deflation, inflation pulses coming through here. And you see the earthquake counts really are reflecting that it was a lot more earthquakes about a week ago than there have been over this past week. So all in a shallow band here. Actually, the Pahala earthquakes are a little bit slower in the recent few days here, but that's normal variation for what you see with earthquakes. There's our map again. And cross section there too. All right, so here's a last month perspective. So our last week was just in here. And we recap this in our summary here, but that's the overall pattern of inflation. Since that drop, we can measure it from about -5 microradians to about +4. So you're looking at 9 microradians, more or less, of inflation over that couple week period. And that pattern is similar as a blue line on the Sand Hill Station, which also has this green line that measures the South Caldera area, which is going through that exact same pattern with a slightly different scale here, but also showed a decrease draining out during the intrusion, settling period following that, and since then, reinflation of the South Caldera. So the South Caldera is still a part of this story here, as part of that expanded magma reservoir, that magma network that's getting more pathways into further reaches of the volcano now. Okay, so for the last month, it's more obvious that the earthquakes from July 22nd to 25th were a lot higher than they are now. We look at the map and we see a bunch of earthquakes, but it's really just this after effect still, with this potential extra little trickle that's continuing to push the envelope here and is gonna, if it continues, eventually cause further adjustments to occur on the volcano, whether passively or with more earthquakes. Hard to tell that. Over the last year, here is how this most recent earthquake swarm compared to the previous buildup to eruption in June with earthquakes at the summit there, and then back to earlier this year as well. And still, over the last 5 years, earthquakes per month are quite high, highest we've seen in a while. So we'll look at GPS next here. And the summit GPS and Kilauea, north to south across the caldera, showed that contraction here on the right side. I'll zoom this in. This is a 1-year plot, so Our data is really compressed on the right end of the graph here. So there is our drop during the intrusion and subsequent recovery showing the summit is expanding north and south across the caldera there. So magma this matches the tilt meters as well. When we go in to look at the Pu'o'o GPS, we see the long-term pattern isn't really changed. It's still contracting, coming closer together. We have this set of data that's further shifted down off the graph, which for a while we're kind of wondering what's going on with that data. And every week we come back and see that it's been fixed. So I thought I would just recap for you guys how suspect this data on the right side can actually be by just representing the images from a few weeks ago. So today we are here on August the 9th. This is on, August the 8th here, 2024. August the 9th, 2023 is when we start. So August the 8th, 2024. And if I go back to 1 month ago, a little bit less than a month ago, here's July 18. And look, we had a similar slope and a bunch of extra data here at the bottom. I'm going to go forward 1 week and another week again. And then our last one, a week again. Oh, no, I got that last one wrong here. Week again here for the last one here. I got to open this in somewhere else so we can actually see it in full size. I'm going to try this again here. Make that one bigger. All right, so there was the first week. And what you might see is if I play these quickly, the data that in 1 week are down low, the next week pop up and get corrected into that regular band. So you go from that to this, then it happens again the following week, then it happens again the following week to where we are now. Maybe it wasn't quite as cleaned up this last week here. But so what I'm just trying to point out is how we really need to be suspicious of this data that seems to be off track at the bottom since all the previous month. We've seen that it's been corrected back upwards to the trend. So nothing unusual looks to be happening on a Middle East rift at Pu'o'o is what we can tell from this. So looking at tilt and at some other stations, we've seen the summit. We have Kīlauea, which is also measuring the summit signal in blue, but perhaps that connection to the Upper East Rift in green here. And that's showing overall a deflationary pattern on that azimuth. So it's hard to tell what's actually happening there, but that does not suggest an obvious trickle going from the summit over to the Upper East Rift. We've looked at Sandhill. So we'll keep going to the escape road, the one that's right on that bend of the rift zone. It also seems to have stabilized to its previous pattern. You can see here, this is that period of time that the intrusion was occurring with lots of earthquakes causing these little wiggles and pulses causing the steps. But before that, there was a long pattern of deflation on this blue azimuth, and it seems to be continuing again here. And similarly on the green azimuth, similar pattern as you saw before as well. So nothing obvious happening tilt-wise right over that intrusion site. So further over at Pu'o'o, now that I load this, we can see there's a signal coming in here on this graph. The signal is not the one you would expect necessarily of magma right underneath it there, because that would be the direction of the blue line here. The green line is the one that points back up and down the rift. And so maybe Pu'o'o is starting to feel a little bit of pressure of magma trying to approach it from the side, but it remains to be seen. One of the questions we have is how will magma interact in this area where Pu'o'o was known to have collapsed and drained to feed the 2018 eruption. And then following all of that, had deep magma coming up to reinflate underneath it. Unknown exactly how far that went or what exactly it did and what it left behind as a blockage or material that would be interacted with now. So a lot of questions around Pu'o'o, and this is an interesting signal to see here. So this is very curious to see what's happening. But like I said, if this were the typical, what we saw at Pu'o'o from the eruption days and magma was about to come out of the ground there, you'd expect the blue line to be going up. And it's a little bit different pattern. So it is wiggling, it's feeling some pressure for something nearby, but it's not quite in the right way presently to show that kind of bulging upwards. And we can get a better idea of that if we look at the GPS. So let's go to our 2-year GPS, and we come to the top of our set here and look at the summit caldera, the first set of 6 stations here. And if you have not seen us present these before, these are panels of 3 components of these graphs at each station. So the top panel is an east-west, the middle one is a north-south, and the bottom one is an up-down. And so we know that the stations are all moving laterally in lots of areas, and those are usually in fairly understood patterns. More telling a lot of times is this up and down signal at the bottom, so that's what we'll focus on once again. And for example, at Kahuna, we can see that the station actually was going vertically downwards following that intrusion, during and following the intrusion, and now has been going upwards. Right? And so at a glance, we can see that with Kahuna, so northwest of the caldera, east of the caldera, south of the caldera, southeast of the caldera, are all once again rising. It's a little less clear, more subdued, a little further away. You get 1.5 miles away to the southwest by Cone Peak on a path of the recent eruption site. And it looks flat, if anything. Maybe it's slightly dropping, but if so, not very much. So stable. And to the south at Ahua, you see that it may have risen a little bit, but maybe is looking to stabilize as well. And once again, we need to be suspicious and wait for the rightmost data points to clean up over coming days here. But so more localized to the summit region and less so to the south and southwest there. And now looking at the Upper East Rift, at Puhimau Crater is 2 stations in a very close proximity to each other. This one is installed more recently. The data only comes in from mid-2023. So it's zoomed in a little bit more. And otherwise, it's the same data as you see over here. These are at Puhimau Crater. So you can see that there is uplift still happening at Puhimau Crater after maybe a little bit of adjustment here as that intrusion was distributing in that first post-intrusion adjustment. So Puhimau, Devil's Throat, is the one that dropped the most, right? Maybe as that magma was feeding intrusions and dikes elsewhere. It's really noisy. It's hard to tell if this is really an up signal or if it's a flat signal because it's got so much scatter in there. But it's definitely not doing what it did before, dropping that fast. It's not continuing to go downwards. It's stabilizing in some fashion there as well. Right? So if any site could be convinced to be losing magma to feed intrusions and inflation elsewhere, it would be this one. But it's not very convincing as such. Right? So you likely would want to invoke the magma supply from within the volcano to be contributing something as well. Maunaulu is very noisy over the last 2 years. So maybe now we can see somewhat of a shape of it maybe dropped down and came up, but within the scatter of the noise that we've had, it's really hard to say anything definitive about Maunaulu. Continuing down to the Middle East Rift, Kananui-Ohamo is showing massive translation to the west and to the north, while also being pushed upwards, right? And that's the signal you expect when you have the inflation by magma building somewhere nearby underground, something like that. This other station is quite near Kananui-Ohamo as well. It's also showing those signals. You can see that some of this motion that was going very fast, in this case to the west, now these data points are clustered closer together, showing the rate has slowed a bit in some of these areas, but it is still moving. Maybe you see a little bit more clustering of the data points here at the right end. So perhaps it's beginning to stabilize, but it's not quite there yet. A little bit further east at Kananui-Ohamo, we're now 10 miles east of the summit, working the bend around the rift zone there. And here, likewise, you are still seeing ground uplift continuing, north movement continuing. The east-west has turned around. It was moving very quickly to the west, and now it seems like it's bounced back to the east a bit. Right? So maybe that means that that first pulse that came across in that area went by, and now the pressure is once again back to the west of Nepal Kane station here, and the KERZ station, which is very nearby as well. These are both just northwest of Nepal. And so maybe here in a zoomed in version, once again, a little bit more clustering in the recent days, right? But still an upward component. There is no such stability there. Okay, further over from Nepal, we don't really see an upward signal at Kamoamoa. Maybe it's beginning there, but within a scatter that exists, you can't really say that convincingly. Certainly you're seeing this northward push, eastward push, right? Suggesting that there is pressure coming, but it maybe hasn't got quite to where it can push it upwards. It's still off to the side more than it's come underneath. And so that's the extent there is between this Kamoamoa area and the Nepal area is where this current blockage seems to be. Right? It's still feeling pressure from the side, but it's not really feeling the upward push yet. Okita is on the south flank. It's been bouncing around a lot, and I think if any of our stations could be showing noise, this is a likely candidate because it seems like it's ping-ponging back and forth. Is it really going back and forth, or is that just noise in the data? It's easier to believe that it's noise. We'll wait and see. It could be ping-ponging too, but we'll see. At Pu'o'o itself, these are the two stations that we have that measure that distance north and south across the caldera. And here's our upward signal. It's actually going still down and still down. And if anything, showing deflection to the north and to the east, right? So similar to that tilt plot, maybe not really showing from the direction of the rift zone, but from off to the side, maybe it's showing that pressure coming at it. And Jacuzzi is a station that we measure the distance to Pu'o'o, and when that data is getting corrected, as I showed the sequence, it seems that the noisiest part of that data seems to be this component right here, this east-west of Jacuzzi, which has been showing similarly this little excursion to the south, but as every week comes by, these are the ones that keep popping back into place within that pattern there. So these are also a little bit hard to believe for now. So we're still seeing signals. We just have to be really selective and filter and use our context, what we've seen over the recent weeks and months and years to inform how we weight those data points. Further over down the rift zone, there's a couple of new stations, RKAR and R931, and neither one is showing any uplift or change from the side either. So that's far enough away now that you're not really seeing that. So that really takes us all the way to the lower east rift being quiet, which I can show all the way here at the bottom. The lower east rift, no other signals either. But also of interest is the fact that the south flank has been moving. So southeast at Idaho, this is a ways off the rift line. You can see there was quite a fast southern movement at first, and now it has slowed once again. Right, here's a pre-intrusion normal, which is still fast, but it's picked up maybe at a slightly similar, but maybe a little bit faster rate, but still slower than we saw during the intrusion. So certainly the south flank seems to be slowing its rate. You see that here at Idaho. You see it at PG2R, Mulivai-o-Pele. See that little curve right there, suggesting it's slowing down as well. So this is southern motion of the south flank. The south flank is not showing any upward movement. It's too far away from that rift area where the magma is injecting underground. But it is showing this southern area. We do have one station, MKAI, Makai, that is very, very close to the rift. Even though I put it in our south flank section, it does show that uplift because it is right close there as well. And this one also not quite clustering yet either, still migrating and moving quite a bit. Its southern component has slowed though, quite fast at first, those first 3-4 days. And here's that last part of the first week, and a more recent week is clustering all within down here. So still moving, a little slower. Kalapana Trail, same story, right over here. Holaipali to the south, there's the same southern movement. Not quite as much evidence of slowing, although there is still clustering happening here. And then that's as far over as the effect is. When we get to MP3R, now we're further south of Pu'o'o, and so we're not getting the same effect at the flank because the magma isn't pushing us from the north as directly. It's off to the northwest. So here we see the effect end between these two stations, west and east. And then we see other adjustments. Kind of point all the way to coast did show some movement early on and seems to have stabilized more so now. And the southwest rift, where we saw intrusion and then eruption in the beginning of June here. This was the beginning of June eruption, and then re-uplifting to nearly the same levels as before the June eruption. And then the intrusion happening, that seems to be still moving downwards. So this appears to be cut off now from that summit pressurization, and it may reopen sometime, and if it does, we should see magma coming back into it and flowing through and then causing this to move up as well. So that's KOSM right over the southwest rift eruption site recently, and further down the southwest rift, there is no effect there. On the southwest flank, that's south of the southwest, on the southwest flank, south of the eruption site, you're not seeing any unusual signals here, either upwards or sideways in any of these. So that's the GPS update there, and we can add a couple more things with our InSAR. We have the Mount project that we rely on for automatic InSAR images. They have a couple of versions. You can have a zoomed in to Halema'uma'u version, or you could have a wider summit view of the volcano, which is more like this. So the more recent image is this one. And unfortunately, all this speckled area on the right side of the graph here, or the map, is all forest interfering with this satellite radar measurement. So in the previous week, or previous set of 2 weeks, I should say, because these are run for 12-day periods and ending at the timestamp in the top left here, we did see some hints of these little stripes down here through the trees at the intrusion site. Right? We really had to rely on the USGS releasing this image that they used, provided by Agenzia Spaziale Italiana in Italy there, to get this wider image that shows that Maunaulu flow field's deformation pattern. So we can't see quite as much from our automatic ones, but what we do see is the image from 2 weeks ago that showed intrusion over here and deformation sources over here to the south, to the west in the Kauai area. Today are showing more of a pattern. It's more like a band that's connecting the summit to the south caldera, and maybe just be a moment of a snapshot in time too. The other interesting thing here is that beyond this, we can use the zoomed in versions. And so I'll go into this one as the one that was from 2 weeks ago. And these are tricky to read, so let's try to recap this here and let's try to make it simple. We have red, call these reds, call these greens, and call these blues, right? Red, green, blue. And if you see it, so okay, if we're looking at this main summit pit of Halema'uma'u, the center of this activity is right here, the bullseye is right here. So we want to look towards that center, and is that center a high or is it a low, right? And to do that, we're going to look at these arrows on the side. The one on the right says away from the radar. So if it's going away from the radar, you're going to see red, green, blue. Right, so if you look in, you see red, green, blue. So in this direction, we're going away from the radar, which means that this is a sinking spot. And that makes sense that during that intrusion, we saw the summit deflate, and we're seeing from this radar how much magma was actually lost in the summit shallow reservoir underneath Halema'uma'u. And if we take that and advance to the zoomed in version that was just released yesterday, now we'll actually see, going towards the middle, you see red, blue, green, red, blue, green. It's going this way towards the radar. So the bullseye in the middle is going upwards now, where it was going down before. So interesting pattern there, right? It's really subtle to see, And this is what the trained InSAR specialists can really pick out really quickly without going through that kind of exercise. But this is towards the satellite, and this is away, and towards and away. So that really reflects that tilt pattern we saw as well, that it was deflating 2 weeks ago, and now it's reinflating again. So that's the full monitoring signal we have for Kilauea here. We can, of course, go back through our main hazard. All this is happening in a national park, so no extra hazard to people, but there is still gas coming from the volcano. So we turn to the VOG Measurement and Prediction Project from Manoa to give us our most recent forecast. Here is the dashboard showing the most recent forecast from the emission source at Kilauea. So this is combining recent weather data to try to predict where those gases might disperse and who they might impact. One caveat, though, is we've seen this for a while now still show 311 tons a day as their SO2 emission rate for Kilauea. We've seen the USGS report this rate dropping for a while, and it seems like it's just is temporarily not being input into the model. So it might be looking a little high as far as concentrations, but as far as where it might actually go, that's still accurate from the wind directions and all of that. So, and it's the same as before. It's in nearby communities to Volcano and a national park and downwind areas and Pahala, Nalehu, and Ocean View that are the ones likely to get this consistent, persistent, low-level emissions of gas from Kilauea. In a national park that's right there near the source, everything is in the green, and visitation to the park is likely uninterrupted. However, if you are someone who is sensitive, then for sure you want to follow the guidance from the rangers and all the signage that's nearby, since winds can change quickly, and if you're sensitive, you want to be careful. So that's the main hazards to people, is still the gas. And we will quickly stop over, touch base on Mauna Loa before we get to our break here. And so here are 3 earthquake maps last week, last month, last year. It's been pretty quiet seismically on Mauna Loa. Earthquake-wise, very low now compared to the build-up to the 2022 eruption. If we zoom into the last year, we see an extra spike here from some deep earthquakes under the summit that didn't really change much at the surface. And here we are, still quite low. If we zoom in again, then we get to this very sawtooth pattern where we're having at most 8 earthquakes in the summit region any given day. And some days, many days, there are no earthquakes registering at all. So pretty slow over there overall. The most interesting thing really is the little tilt excursion we saw. We've seen little variations like this before that were unexplained. And this one, I think we can't conclusively explain either, but it is suspect that we see that big pulse on Kilauea showing up even on the InSAR, and that happening with a slight delay where you can imagine pressure that would actually build in Kilauea and then start closing all the gaps towards Mauna Loa to eventually reach Mauna Loa summit. That could take a couple of days as a volcano swells and puts pressure on the rock surrounding it. So that's what I lean towards, but nothing conclusive, and other ideas are also possible, of course. Nothing else to mention with the earthquakes or the tilt zoomed into the last week. That's really Mauna Loa. So to wrap up our first half here, we'll come to the USGS Volcano Watch, which this week details Kilauea's 2019 and 2020 water lake that occurred for those 9 months or so between the eruptions, between a collapse of 2018 and ultimately the eruption of December 2020 that boiled away that water lake. So it's been 5 years. It was late July 2019 that water was first spotted by a local resident from the helicopter. I thought I would go through this because they do actually share some follow-up research in here that is worth mentioning to you guys. The first thing to note is that here is a picture of the water lake in its later months when it was turning a more orangish, right? And that's reflecting the presence of various oxygen and sulfur-bearing iron minerals in the water. The green at the edges is caused by an influx of iron-bearing groundwater that has not yet had time to react with oxygen in the atmosphere. That reaction is akin to rust, right? When you have iron rocks bonding oxygen and turning reddish. Similar minerals occur that are unaltered or more yellowish, like the sulfur on here, as well as the lava rock here in the background too, that has lots of iron in it, probably in the range of 10% more or less. So what can I highlight for you guys out of this article here? They've looked at all those variables: color, the level, temperature of the lake, to try to understand what was happening there. They found that the lake level rose steadily. The temperature rarely varied. It was always around the same 80 degrees Celsius, 175 Fahrenheit. They were able to sample the lake 3 times using drones. This occurred in October 2019, January 2020, and then October 2020, with very little change in chemical composition of the lake during that year in between. They note that the lake had a low pH, about 4, acidic, but not as low as most volcanic lakes that are acidic, which are usually around pH of 1. And they noted dissolved iron, magnesium, and sulfur. So here is what is newly reported here. They thought that, so first they determined that the iron and magnesium came from the rocks themselves, including that initial greenish color due to the form of iron that exists in Kilauea basalts. As that iron in the water spent more and more time in the lake and in contact with oxygen in the atmosphere, it transformed to another form of iron that creates orange and brown colored minerals similar to rust. That explains why the lake changed color from green to brown over time, and why there was green water reappearing at the edges, showing that there was new groundwater coming into the lake all the time there. Initially, HVO thought that any sulfur in the water might be the result of the lake dissolving sulfur gases, right? A process called scrubbing. We talked about this a lot in those months in between there. And here is the new information. However, careful study of the type of sulfur in the water, along with the acidic but not very acidic pH mentioned above, all of this reveals that the lake's sulfur was instead derived from alteration minerals. In other words, minerals that had been deposited on rocks for years and years, and then later dissolved into the water. So all that discoloration we see like on the surface of the pad of the summit of Kilauea now, that kind of stuff. It's been accumulating on the rocks for a while, and then water comes into it and dissolves it, and it's not actually going straight from its gas form into the liquid to be absorbed. So that's a fascinating follow-up there. And there was actually no scrubbing occurred, which means that there was not any extra SO2 being released ahead of that first eruption in December 2020. There is another interesting note here. I mean, they do say that it was lucky that the lava erupted next to the lake rather than through it, so no large explosions materialized, but instead all of it was boiled away. There's another line I missed in here I was going to highlight for you guys. Here it is. The water was so warm that at least half the groundwater flowing into the lake evaporated away rather than remaining in the lake itself. So that's something that's also interesting to note that I don't think was expressed quite so clearly before. So interesting stuff following up 5 years after that water lake. So yeah, that's the follow-up to that. Since there is no big hole in the ground that intersects the water, we don't expect to see another water lake for a long time. But if we do, we'll have a better idea of what's going on now that we have some modern take on water occurring on Kilauea, which we've never had before. And so it's 5 years since 2019, and that's the USGS volcano watch for this week.
Yeah, pretty interesting stuff. I remember that whole time, we were talking about it every day that we did our live streams, the lava. When we first saw it, we had friends going up immediately to try and get photos and from the airplane, and the some really interesting details about half of it evaporating and some of the other things that we learned in there. The one that I was kind of thinking about was because we didn't know exactly how the mechanism for the explosions, that was part of the talk at the time. And for them to say, thankfully the lava came up on the side of the lake instead of under it and evaporated it from the top. And it was like, that was kind of what we were talking about too, is it didn't come up directly underneath the lake. And that was the first time that I've seen them make that distinction where in writing. I know we've heard it from people before, but to see it in writing being like, if it came up directly under it, that's probably how you get I was like, okay, cool.
Well, I'm not sure they went far as to say it like that. You're kind of adding a little bit more there. They're just saying that, like, we have no idea what would have happened if it came up through the water, right? That's basically it. We still don't know what causes those explosions, and certainly explosions would have been more on a table had it come up through the water. Clearly, they weren't, since it didn't, and we didn't see them. So I think that's still where we are. We still don't know. And the last I really heard that was convincing was more to do with the ascent rate of the magma itself rather than anything to do with the water up the surface, really, as far as what kind of explosions you actually get. So we'll get more from that when we hear more. And there was one volcano watch a few months ago that talked about the looking at the explosive ash from Kilauea's past and trying to determine whether it was water mixing with the olivines, and it didn't really see that really at all there, right? So that's why they're thinking maybe it was the ascent rate or something like that. Different kind of magma, different kind of build-up process, maybe from deeper down. Who knows? Who knows? Maybe that the whole correspondence to collapse is because if you have a collapse, that means you don't have a shallow magma chamber as likely anymore, and that requires the magma to come from deeper down, and then it can come up faster, and that can cause, there's other kind of mechanisms you could consider as well to have water off to the side, right, until it actually gets to the very top. And one thing that I've said, and I'll keep repeating, is that with the way groundwater works in Hawaii, almost every single eruption we have comes up through groundwater. Almost every single one does. And not every single one is creating a giant explosion. Sometimes they do, right? Even down, when we have collapses on even prehistoric on a Lower East Rift, we have some big craters down there that actually are from big steam explosions that can occur, right? So yeah, it's all, that's one of the biggest question marks. And it kind of comes down to, if something happens so infrequently that you only see it once in a great while, then it's hard to really pull out any patterns and say anything definitive about it. So yeah, that's why it's totally, I mean, we had to all be very careful about the possibility of explosion. We just didn't know any better. And if it were to happen again, we'll probably be equally careful again, because we still don't know what exactly was responsible for that. And we'd rather be careful and cautious, right?
And after 2018, a lot of the knowledge about the mechanism kind of got thrown out the window with the collapses and what we learned then. So that's important context, is that it was thought to be known, and then we watched it happen, and it's like, okay, going back to the drawing board, what did we just witness, right? And that was kind of all the scenario around 2018.
Yeah, and so we're just very slowly getting more information about the water and the sulfur dissolved in it, and we got more information about the ash and like what kind of explosions there were, and it's coming in a little bit here, a little bit there, and over the course of time, we'll kind of build this new idea of how this might actually work as more support falls into each of those various camps, right? So we'll just wait for that to play out over the months and years here. So yeah, that's all Kilauea this week. We can say some thank yous.
Yeah. Do you want to do some questions after that?
Yeah.
All right. Let's do some thank yous, and we'll do some questions. All right. I will go ahead and invite Lou to join me on stage here to talk about some of our recent our fundraising and what we got going. So, Lou, how you doing? I'm good. How you doing? All right. So yeah, we start out. I'd like to thank everybody for tuning in today, especially in this time when there's not a lot happening. The time where you can really talk and dive into the details of all these different aspects of our volcano. So we appreciate you joining in today. The likes, of subscriptions, the shares, all that stuff really does help with the algorithms. I know you guys hear it all the time, but it's true, and we appreciate you for being here. So we'd also like to thank the Puna Strong and Kilauea recovery grants through the County of Hawaii and the Hawaii Community Foundation. They're helping to make this type of production possible, as well as all the other projects that we have going. So just want to recognize them and their support there. And I think that's it for me, Lou. Go ahead, and I know you got a bunch of stuff to go through.
We got a few things to cover here. Let me hit the roll here. Of course, thank you to all of our independent individual supporters. We raised $2,954 during our last donation drive. So thank you to everybody who pitched in. I really appreciate that. It's never too late to donate. hveri.org/donate. You can always get us there on our website. And we throw our big mahalos out here to all those who collaborate with us here across the state. We can't do this without everybody's support from all of these collaborations that we do and all of you. So we truly appreciate it. If you're still interested in collaborating with us or sponsoring us for anything, you can reach out to us on our website, hveri.org/contact, and send us a message, and we'll talk. That's what I have for us tonight. Thank you, everybody.
All right. Yeah, thank you, Lou. And yeah, that's our donation, or the midpoint. We're now going to go in, do questions and answers before we dive into Lahaina and talk about the anniversary 1 year later. Thank you, Lou, for joining me, and I'll get back Phil back in here. All right, there we go. So yeah, we got some questions here. Not a whole lot of questions. One from Buster comes out and asks, can inflation from the South Caldera Reservoir cause an eruption in the eastern rift zone, considering the amount of fresh magma in there right now?
Yeah, that's a good question. I think in decades past, it was thought that the connection from Kilauea to the East Rift Zone was a pretty shallow one, where it had to have gone through that shallow magma chamber. But in more recent decades, that has shifted to a preference that the connection to the rift is actually through the South Caldera Reservoir, perhaps through the Kīlauea Reservoir adjacent to it as well. It's pretty complex down there. We're not sure exactly, how all of that fits together. But certainly in the past, both of those pathways have been described, including that direct South Caldera to the East Rift Zone as well. So yeah, Buster, yeah, it's a good question. And that's when I say, is it all going through the summit and kind of trickling through that way? And in everything that goes into the rift, we expect to see a corresponding signal at the summit, or might there be a bypass, where it can actually fork and you have something feeding both the summit and the East Rift, because you have that path that splits off at a deeper point off the South Caldera. So yeah, I think that's remains to be seen, because following 2018 and the collapses, reinflation, we've seen the Southwest Rift get injected, that whole south flank wiggle and shimmy to the side. When it moves off of the Southwest Rift one way, it kind of pinches the Southeast Rift, and it moves in the Southeast Rift, it pinches the Southwest Rift. So it's kind of doing this little wiggle. And who knows exactly how it's pinching, opening, and closing, and what state it is at in any given moment in time. Can't quite predict that, but that's the pattern that's happening there. So yeah, we'll have to wait and see.
Yeah, good question. Got a kind of a fun question here for you, Phil. We don't have a lot today, so I'm going to throw this one in for you.
Fun for you mean, huh?
How long can I huff Vogue? What will it do to me?
Don't huff Vogue.
Don't huff the Vogue.
We're here to help everyone be safer and be more protected, right?
Yeah.
But what I can say is that we do have that when we talk about the VOG dashboard, the VOG measurement prediction page, and put this back on the screen here. Right, so from this project right over here, there's all kinds of information on these pages here, right? So you actually can read about all the stuff that's in the VOG, how the studies that have how it's affected people, all those things. So like VOG and health, for example, here in VOG and health. Go to the International Volcanic Health Hazard Network. What is VOG? Forecast, air quality, health effects of VOG. So here, let's really try to answer your question here. Right? What would actually happen? Impacts could be, yeah, all respiratory stuff through here. Irritation, eye, nose, throat, skin, coughing, phlegm, chest tightness, shortness of breath, increased susceptibility to respiratory ailments. People also report fatigue and or dizziness. So that is the why we suggest that you do not have VOG, and always want to protect ourselves, right? The worst thing that we had in 2018 was the possibility of passing out. The VOG was so intense. I didn't remember that.
Yeah.
It's like, does my respirator have enough life on its cartridges for me to make it in and out today? Was something you have to think about, because it was so
you notice if it wasn't sealed correctly, type of thing.
Yeah,
real quick.
Yeah,
but I thought you, when you're mentioning 2018, I thought you were going to say something along the lines of the question to USGS about cooking marshmallows on the lava, because that seems like the same type of bucket this question was pulled from.
Yeah, that's a whole other can of worms, right? With cultural
sensitivities
and what happens here and what happens on Iceland and all. Yeah, so let's just leave all that to the side and we can move on.
All right. Yeah. And finally, we just had this one come through. Dawn asks, how many new cameras and GPS sensors have been installed in the Upper East Rift? I don't think we have a count, but there's been 3 cameras, 2 cameras. Depends if you count one of them.
The cameras come and go is a thing, right? So like, right now the KO camera is the one I was looking from Maunaulu back to the north is not actually transmitting any data. I don't know if that's because it just had an issue or if because it took it down.
And also you have the distinction of a new camera versus going to an old camera and changing the view of it to look where you think it's going to erupt at. Right? Because they've done that a few times with a few different cameras. They're not new, but it's a new angle. We didn't see that before.
Right. So there was something I forgot to show here, actually, that there was some maintenance done on Mauna Loa's southwest rift under multi-gas. And it's not exactly a camera, but here there's noting that they have gone and replaced the batteries and the instrument with when it was calibrated. They do note, on average, batteries at stations last or change every 5 years, while continuously monitoring multi-gas is replaced every 2 years. So there's an example of more of that kind of sulfur scum building up on the surface where there's a lot of degassing. It might look like snow here. This is called sulfur cone, in fact, right? Because it's got so much of these deposits nearby, visible from a long way away. There is their installation, solar panels, box, the multi-gas instrument back over here, radio transmitter, and a little closer view. We got some wires feeding into this box, weighted down because it's super windy up there time to time. You open a box, looking down on the bottom of the box, there's all the guts of the thing, all the different feeders for different pathways of gas samples. Top of the box, where all those feeders come in and get analyzed by all different components. There they are, replacing everything, putting it all together. Far away view. So they are still going out and doing maintenance all over the place. This was on Mauna Loa. But to get back to the question, I can just point out the USGS map. Is it this one? Yeah, let's turn on our GPS instruments. And I can point out in here, right, which ones of these are new. So KERZ is new, but right next to it, an old one there. So that's one new one. Yeah, these two over here are new. RKAR, R931. We know that there are ongoing efforts to get more stations established down here in the Lower East Rift. There have been some challenges there, but that work's ongoing, we know. We know there was a new station over here in the desert that we picked up during that recent southwest intrusion. That one's new too, so can't give you a number, but they're kind of southwest, they're Middle East, and they're actually working all the way down to the Lower East Rift too, although those are not quite online yet. yeah, cameras come and go. But yeah, there are a lot of cameras, and that's really great to see them at least put something up so everyone has a chance to see, right? And now we can argue about, is a camera live streaming or is it just an image every 5 minutes? And that's kind of, you know, a way more advanced, better argument to have than, can we even see anything happening at all? Or did something even happen in the first place? Which is where we were not that long ago, honestly. Dane, can't hear you.
Oh, yep. They have the tech now where doing a deployable temporary camera in the field, say a day, to be able to capture something in an unexpected spot is possible, right? And
yeah,
it's only getting more and more bandwidth and technology advancements, so should be miles ahead, you know, in the next few years type of thing. We're expanding quickly, or they are.
Yeah. Your biggest challenge is what happened in the last eruption. The eruption didn't last long enough for anyone to get out there and put a camera out. Right? That's just, that's this volcano doing what it does.
Mm-hmm.
All right.
Yeah. Want to go ahead and...
Yeah, so let's move on. We'll move on to show the Lahaina fire anniversary. So first of all, as I mentioned at the top, right, this is why we do this, as you know, to improve disaster preparedness, response through education, right, and also building networks and working with our local officials to improve our communication lines and all of that response. That our goal is to prevent what happened in Maui, similar issues we saw emerge in 2018, but also other issues as well that were just very particular to that situation. So I wanted to point out a couple of resources here, and maybe I just kind of share with you guys what there is out here. There are two reports I'll share with you guys today, not in super detail, but one is this Maui Police Department preliminary after action report. And so they actually put this out fairly quickly in the months after that fire, and there's a lot of information in here. So if you're looking for how the police documented this is a great document, and I believe that Dane and Lou will make these links available in the chat for anyone who wants to look further into this. But to start off, I'm just going to highlight a few of these images and content in here. There were actually 4 different fires that day. We talk about Lahaina. That was the most impactful one, of course. But there was also the Kula fire, the Olinda fire, and the Pulehu/Kihei fire. Right? All these more in central Maui, and then Lahaina and West Maui. So just to give you some orientation, we're going to focus on Lahaina, although there was a lot happening other places as well. And to kind of illustrate what this might have been like, I'm going to just come in to show you what the sequence of events was for the police. So I'm not going to read every single thing in here, right? But I just want to point out that where they have something written in blue, that's the Olinda fire. When you have something written in green, that's the Kula fire. When it's in black, that's Lahaina. And when it's in red, it's Pulehu/Kihei. So what I like about this report is it gives you a little bit of a real-time feel for how much was going on at the same time, right? You can see that we're looking at Tuesday, August 8th, right after midnight is when the sequence begins. So all the blues are the Olinda fire, right? With also having wind up by Kula already knocking down trees. Yeah, so up through, call it more or less 6 a.m. or so here, they are doing a lot of work on that Olinda fire, but also they are starting to note in these black lines effects on Lahaina as well, stuff blowing around on Lahaina, right? So you see that they're kind of starting to have to split between Olinda and Lahaina, but really throughout the morning, most of the focus is upcountry, on the upcountry fires. And then you can see Kula fire comes in as well. So now we have 3 different colors coming in here throughout the day. We're getting into 8 o'clock, 10 o'clock. In case Well, so here, what I'll do here is I'm going to show you what the other report is going to be, and it's this one. This is one that's basically known as the Comprehensive Timeline Report. And this was put together by the Fire Safety Research Institute, FSRI, these guys here, at the direction of the State Attorney General. So that's who did this work, but was commissioned and then released by the Attorney General from the state. So this has a whole bunch of information in it as well. But I want to just maybe start off with giving you a broader summary of the fire here, of what actually happened, just to recap and bring us all to the same page here. And I'll try to summarize here as much as I can. So before August 8th, Hurricane Dora was passing to the south, 500 miles away, and created a pressure gradient that brought damaging winds, low humidity, and higher risk of wildfire. So alerts were put out in advance. The Maui Emergency Management Agency, MEMA, partially activated their Emergency Operations Center, their EOC, that prior evening, August 7th. Right? The winds arrive early on August 8th. We see the reports from the police right after midnight or so. One of the big issues that there was lots of trees and utility poles and power lines fell, blocking roadways and making evacuation challenging, both upcountry and on the west side. Enabled by dry fuels, sustained winds, and a dense urban landscape, the fire began near Lahaina Intermediate School at 6:35 a.m. That was a Lahaina AM fire that began and was quickly attended to by the fire department. Although that was not their primary concern at the time, their primary concern was the Kula fire upcountry. And so they were really sending their maybe to call it the second team, right? The deployment team was out over here. They addressed this with the help of private bulldozers and water tankers, soaked the whole area, and report that fire extinguished at 2:17 p.m. So 6:35 a.m. to 2:17 p.m. They're working most of the day putting out that first fire. It didn't take long after they left, though. 2:55 p.m. is when it flares back up, and now we call that the Lahaina PM fire, or Kīlauea fire. Right, the same location as the earlier fire, but the winds were a lot higher by 2 p.m. than they were earlier. Right, the winds have been picking up throughout this entire time. So that's what drove the fire, was that reactivation of the fire, Lahaina PM fire. It affected all evacuation routes. Cross evacuation routes went all the way to the ocean, overwhelmed the efforts of police and firefighters to evacuate. Many residents were trapped. One thing that's reported is that the winds were so strong that smoke that normally would billow upwards was all hugging the ground, and so everyone was in the middle of all the smoke. People couldn't see hardly anything, and it was dark, and it was really disorienting. People were suffering effects of smoke inhalation pretty fast because of that. So they talk about how on Lahaina Luna Road, vehicles became stranded. Civilians were trapped by the rapidly encroaching fire. Similarly, on Kahua Street, where there was also numerous lives claimed. And everyone who could opened up, locked gates, cleared roads. I heard the fire department actually cut down a street sign at one point to just try to get access to move around the area. As the fire was moving quickly and roadways remained blocked, several crews of firefighters became trapped near Paola Street by the advancing fires and were overwhelmed by flames. Fire apparatus became entangled by power lines or were unable to evacuate due to obstructions and had to be abandoned, further hampering efforts to combat the blaze. So not only are they losing the fight, they had to abandon their firefighting equipment due to it. One firefighter rescued 7 colleagues, including an unconscious officer who required urgent medical attention. They gave this guy CPR. So it changed from being a wildfire to an urban conflagration, where it's jumping from building to building, and there's too many buildings catching fire too fast that the fire department can't do anything about it. All the embers carried by the flames were hitting all the downwind properties that might have already had damage with roofs ripped off or siding ripped off, so they were extra exposed to these embers and fire, and so many of them actually caught as well. Some parts of Lahaina had failed water pipes, and so in a couple areas in central Lahaina especially, the fire department tried to hook up the hoses and got no pressure and had to move to a different hydrant. Not as widespread as you might think, but it did occur in a few places, kind of in the later part of the evening, or early evening areas. And so a lot of different things happen there, right? And so in the aftermath, questions linger about warning systems, evacuation planning, preparedness. You can go further to climate change, urban development, encroachment, and all those kind of things. So I'll leave that summary there and just come back to just recap what it was like for the police here, right? With these different colors of statements here, right? So you see the black coming in there. This is all wind damage because a fire is largely being contained, 90% contained by 8 a.m., but not declared out until past 2 o'clock. So they're still dealing with Kula, Olinda. Power lines are falling down all over the place. All over the place. Kula is flaring up. Look at all this green through here. There are false alarms coming in. I read one little note that there was actually in Lahaina some steam vent that someone reported as fire. I had to go and check that out. It was actually just steam. And then they went about their business. But obviously every call you have to check slows you down a little bit there. So things keep happening. There is like some of that roofing and siding blown off. Look at that roof right there lying on the road against the power pole. We're seeing how much is going on all over the place there. Power lines bent over, it's been snapped. That's the traffic light there. But look at this one leaning behind it all the way over there. Smoke coming, how low to the ground the smoke was coming in, how quickly visibility was lost. You went to a situation like this where you really couldn't tell what was happening, where, or what was going on. Really chaotic and crazy there. And so I'll just kind of scan through lots of going on, explosions happening in the neighborhoods going on, possible fatality, but they can't confirm, they can't reach the location because the fire is in the way.
From our experience with
evacuations. What's that?
Saying from our experience, those random explosions, probably propane tanks, because that's what they were when we had them. Just whatever tanks that in people's houses exploding, pressure tanks.
Yeah, likely. Yeah, there are lots of cars were on fire. There's all kinds of stuff. Yeah. The fire damaged everyone's. The houses were just incinerated. So anyone who had any kind of PVC water pipe, that water was just pouring out in the ground. That's partly why there wasn't any pressure in some areas of town, is because all the houses were all leaking water at the same time.
Right.
Until the next morning when it could come and hit all the manual shutoffs. Right. Trees there. So now we're getting into everything is in the black now, right? Once it gets to about 4 p.m., now it's all Lahaina from this point on. Yeah, they have to go and actually, if you look through here, they evacuate a lot of people from a lot of different places. They evacuate all of Waine'e Street. They evacuate Keawe Street. They evacuate Kilauea Mauka. They evacuate. So they're evacuating as many places as they can, right? And where you see the fatalities is maybe just the areas that they could not reach. There were so many places, and they did a lot considering how much was happening at the time, right? So here you see the 502 Maui Fire Department Mayday call. CPR in progress on a firefighter on Shaw Street. Evacuate Kīlauea Street, Ho'opili Street, Hawaiian Street. See, they're going. When a police department isn't there, they're just trying to use any kind of hoses to fight water. Right, here they are. That's actually a police with a garden hose. So they're trying everything they can. Right. Later on in the day, they actually start encountering combative residents. They try to evacuate people. People refuse to evacuate, and they have to spend extra time dealing with that, or just move on. The people are making 911 calls, like including one from the coffee bean and tea leaf. They go there, respond, and rescue them all and get them all out of there. So there's a lot going on that wasn't actually coming out at the time going on here. Lots of evacuations happening all over the place, all one after the other. But really, the truth was that by this point in time, by 6, 7 p.m., there were already a lot of fatalities, and that was just due to the speed of how the fire progressed, really. So it really goes on. Here's 9 p.m., 8 p.m., or 7 p.m., 8 p.m., 9 p.m., goes on past midnight until around 2 a.m. or so is when things really seem to be slowing down. Right, by the next morning, that's when they start shifting to cleanup mode, and the police department is the one was running the morgue, it appears. So that is what they do for a large part of the rest of this report here. So that was one thing the police was dealing with. While I'm on this report from the police, I will highlight one other aspect out of this. This is a almost 100-page report, 98-page report here, so I'm not going to show you hardly anything of it, right? But it is here as a reference if you guys want to go and look it up. But since this is our little sphere of what we do here in Hawaii Island, and to note what an environment this creates online when this is happening, they include in this report their misinformation, disinformation, malinformation, whatever you might call it or how you categorize it. All the different things they're having to combat online to get people the right information. So this is all false, right? False. 183 bodies washing up on the line. That never happened. Directed energy weapon, never happened. Actually, Island News saying roadblocks. The police were actually having roadblocks where that wasn't actually what was going on in the image here. Right? They talk about bodies, hundreds of bodies washing ashore. Not happening. Here's another one of those directed energy weapons, even though in this case, someone actually flagged it. That was not an event that happened in Hawaii. It was actually from another place at a different time.
Yep.
So
interesting community note from Twitter.
Yeah. Yeah. And look, check mark on there too.
Yeah, of course. Why not?
Yeah.
So the thing that, stood out to me and still stands out to me comes at the very beginning of the whole report when they go, so the fire started, and then at 2 p.m. we called it out and we left. That's the part of no return to me. You left. I know there's other things happening, but that's the thing is if somebody stayed there and babysat it and mop up operations, this whole thing could have been avoided right then and there. Right. And it wouldn't cost anything, right? A little bit of water in one guy's time for the day, or 5 guys' time for the day.
Yeah.
A volunteer.
What the cost was to them was like, is Kula going to burn out of control? And we're going to lose Kula. People are going to die over there where they can't evacuate and all the roads are blocked also. That was what was on our mind, for worse or better, obviously. But that's what they were thinking. Yeah. And
we
can say they should have known better.
Delegating tasks, something. You can't just leave. That can't be an option.
Yeah, it took so little time, right? It took half an hour from them leaving to coming back. It was really, if they just checked one more time, they would have noticed.
Those things, in California, those operations after a fire, the fire might take a week, and then the mop-up operation take a month.
Right.
Just making sure every little bit of that thing is out underground.
Yeah.
Because that's where they store. You'll get everything out on the surface, but underground, it's still there and live.
Right. Yeah, and so, I won't speak to the resource. I will point out that when we come, so here's the Maui County Police Department badge with the commemorating Maui Strong in honor of all those who lost their lives. I just want to show that on screen. Then we come back to our timeline report here, and this report has a lot of information. I'm not going to share all this, but I'm not an expert. I can go through that. All the fire department resources, movements, everything is in here. So if someone wanted to see how many engines did they actually have, where did it actually go, in what order, that information is all in here for someone to actually look at. And so it may be that they didn't have enough resources, or they didn't put them in the right places, or, we can say that obviously in hindsight, but I'm not expert enough to say that they should have done it, this or the other thing. I just don't know, right? But I am glad that this report's out here. I was, lamenting, earlier, this is really great to have that this was done so quickly. I wish we had this for 2018, the eruption in Puna, right? But it wasn't the same kind of response nationally and statewide here. So we've been really assembling versions of this like for the last many years, and amazing. All of Lahaina's information is all here in this report right away. So. We've done a summary. I want to show you guys a few more things from this report. Let me start off by just showing, they go through like all the stuff, like history of fires, like, how does the water system work? They're all gravity fed, by the way. There's no pumps in that water system. So like you couldn't lose, losing power wouldn't, they didn't lose power, but it didn't, that for treatment, but it wouldn't have affected anything anyways. It wasn't that. All kinds of details in here. So here is something I thought was a good illustration of a map, right? Here is the progression of the fire, where it began from and where it moved. And this is not telling you exactly the sequence, but like you can clearly see the fastest route was that way. And then it actually then starts fanning to the sides after that, right? So most of the impact was really right in here, although it was, that was where it was the most fatal, I'll say, although it was also bad everywhere else, obviously, too.
Yeah.
So there's a lot of this report that actually goes through hour by hour, right? So, for example, this is the overall big picture of the thing. Here is like all our data points that they collected things from, and then they go and zoom in. So right here of that map, we're going to start off with hour 1 in this little window right here, 4:55. The fire is down here at 5:24. That's your first sweep right there. I'm sorry, 3:24, 15:24. Right there, right? So that's when it's really starting to come down. And I won't go through every single detail here, like I said, but fire starts officially at 2:55 p.m. And then I'll go through and say in hour 1, where did that progression go? And in hour 2, where did that progression go? And go through area by area, street by street. And so all this detail is in here. I'm not going to go over it all because it's way too much, right? But if you are curious, a lot of information is recorded on here. You can just see by me scrolling through the detail that exists. 8 hours in, 9 hours in, 10 hours in, and finishing 15 hours in over there at the far north and south ends of that impact zone. So that's the progression map there. There is, from here, all the Maui Fire Department response, staffing, A watch, B watch, C watch, who was on which watch, at which days, who was doing exactly what. So all the assignments of who was assigned where, right? Each of those resources, what every single fire engine 3, what was engine 3 doing? And there is several pages of what engine 3 was doing. What was Wildland 3 doing? There's several pages of what Wildland 3 was doing. Ladder 3, all the different vehicles that were involved. Engine 11, Mini 11 are in here, right? Everything is in here. So you could come through and do much more than we're doing today. We're focused more on what can we learn and how can we try to help with these issues moving forward, which is where we come back to 2018 when we get through a little bit of this recap here.
And of course,
so that's all, Molly.
Of course, we're focused on the communication aspect of everything. Things like the water lines failing. We're not going to solve that problem. That's not us.
Yeah, no.
But we can do the communication breakdowns, the flow of information, things along those lines. That's what we're trying to address.
Right. It's going to take a lot of different facets for sure.
There was also, I was looking through the supporting material for this. There's so much in here, but they actually have a spreadsheet with all of the dispatcher, all of the radio chatter that day. And not only that, for like 2 days prior and 2 days afterwards. It's 11,000 lines of entries. It's just like, wow, they got it all in here. At least it's here. So if somebody really wanted to go through it, there it is.
Yeah, I'm still going through fire stuff here, right? Just so you can see, right? Event logs. That was all the Lahaina fire. Then you also have the other fires are in here too, because there were multiple fires.
It's worth mentioning too that day we didn't do anything on the Lahaina fire ourselves. Why? Because we had fires on Big Island that we were dealing with that day, right? There was one at Mauna Kea Resort. There was one by Kauai, and one in Kohala that day. And those fires to us, they're right on. We had evacuation orders in place. They were fast moving fires, same situation, right? We just got a little lucky on it, and have some very skilled firefighters and some supporting structures out here to deal with it. But it was still crazy, right? It was still breakdowns of communication. There were still issues, even though we avoided the catastrophic events.
Right. Yeah, some of the issues they didn't deal with that were kind of unique. Like they couldn't have any air support, right? They try to launch air support, and they basically say that these are subconditions for flying, and they just go back to base because it's not safe to be in the air.
Yeah, it's too windy.
Yeah, so that really hampered things as well. They go through, so that was all the fire. They include, there's a police response in here too, and all the dispatch. I just showed you a police report, so I won't go through any of this thing again. All the traffic control challenges here, right? All, what happened? Down utility pole, traffic signal out, all a tree in a lane, traffic signal out, power lines down. Like how many times, how many different places this occurred over the course of this spreadsheet of that fire there. Right?
Again, I wish we had this for 2018.
Yeah, that's what I was saying, right? This is actually a great compilation of all
except this thing is 120 pages or 200 pages.
199 pages.
Yeah. And the fire itself took place over the course of half a day.
Yeah.
And 2018 was over the course of 3 months plus.
Right.
So you're going to you'd end up with a layer of encyclopedias, essentially, trying to do 2018 like this. Really detailed.
The reconstruction is amazing. Like here's a map of the fire at different points in time, from 5 a.m. to 11 a.m. Here's the fire, and their scale is such that like primary road congested is red, heavy congestion is dark red. If it's open, it's green, right? So like the fire is all the way up here, and look, there's congestion already everywhere, and largely because all down trees. This is before 11 a.m. before the PM fire.
Right.
And so there's that one. The next version there, now it's getting heavy congestion through here. The fire is starting to move down. The next one, fire is moving down. You're starting to get gridlock both directions there. The fire is all the way down where the cars are stuck now. Right? So you kind of see the progression of how that went too. So a lot of detail in here I'm not talking about, not going over. There's a lot of information in here. Direct rescues and evacuations. Look at how many they did. A whole table of those. As far as the deceased, there's a lot of misinformation on that also. So to try to correct and address that, let's make sure we're all on the same page here. Right here is the breakdown by gender. It was 61% male, 39% female. By age, you see the numbers there.
So the concerns about the kids being home that day because school got let out and the kids got sent home and they were there for the fire. Comparatively speaking, this really
hit the elderly population disproportionately.
Only 3 under the age of 19, right?
Right.
If I recall correctly, at least a couple of those were in a vehicle with their parents, right, trying to get away. So what you mentioned is true, right? There was no such thing of nothing happening. None of this. There was none of those many multiple storylines about the kids turned out to be true. They weren't getting taken anywhere. They weren't extra. There's none of that happened actually. In hindsight,
it was the retirees that at that age roughly that really got it.
Right. Yeah, and if you imagine how this fire actually progressed, I won't go through every little detail, right? But if you do go through and you examine, like, okay, like where were most of the fatalities, and so I can do that next, right? So let's look at that. Where were people found? Gray is outdoors. Light blue is in a vehicle. Dark blue is in the ocean, in a structure, and darkest blue is in the ocean. So 1 person was found in the ocean, 15 in vehicles, 42 in a structure, 39 outdoors. Right, so that's striking to me. That so many people were actually caught outdoors, and still couldn't get away. Right, and it makes sense when you realize that you had to actually be able to make it to the ocean and get in the ocean, be in the ocean to survive that. Right. So that's the type. There's more information than that. So here is the map of Lahaina, and they break down 3 different areas: central, north, and south. In the north, you can see there were 1, 2, 3, 4, 5 fatalities. In the south, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that includes the harbor, a couple by the harbor right there. And in the center, I'm not going to count. That's all the others. All the rest are right here in the center. This is Lahaina Luna Road right here. Right. So when they talk about a fire going down Lahaina Luna Road, they're talking about it sweeping across this area in this direction. And look at this cluster right in here. Every number is an individual. The red dots are a location, right? But you can have multiple individuals in one location. So that's why you see so many people in the same structures all through here. Like this was really, and here a little bit too, right? The worst of it. So if you look at when did a fire actually sweep through here? It was within a couple hours, right? So like by 6, 7 p.m., this has probably already happened. And now you're dealing with all the stuff on the sides. So they worked all throughout that entire day, throughout the entire night. And, it may have looked like there wasn't much to show for it in the back end, but they did a lot of work here in the south and a lot in the north and in the south, right? That's what you can see here. And that's where the fire moved through later. When we moved through fastest and quickest, when the winds were the strongest, that's where it really did the damage. So you have to wonder what more could have really been done if this environmental conditions were so challenging like that, right? So just trying to, once again, recap the information so we can try to correct anything that was faulty back then. This report goes through, it actually has, what was Hawaiian Electric doing that entire time? What were they reporting as far as equipment down and problems that they had? All of that, right? All their evidence is in here also. The water supply, right? Like what was the issue with the water, right? So I can read you here what it actually says. Can
you go ahead and find the toll? How many deaths were there in this thing? That's
102.
102.
102. Yeah. So 101. Yeah. 101 officially got identified in that few months following, and I want to say it was a few months later. There was someone was still in long-term care in hospital, finally passed, and got added as 102nd. Something like that, if I recall correctly.
Right. So
102 is the answer. Ultimately, the numbers were really off at the beginning. The numbers were a lot higher in the early days, and settled back to 102 ultimately. Yeah. So they did note that there was water available everywhere, except that there were, during the event, water demand in parts of Lahaina exceeded the ability of the water storage and distribution system to deliver sufficient quantities of water. So what they're saying here is that once the fire started burning all those pipes and letting out water, then the pressure in the water lines dropped, and very little water was available for use in firefighters in central and southern Lahaina. Should be noted that water did not fail in all of Lahaina. Parts had service throughout the fire. It was most common in Central and South Lahaina that it was short. However, the water supply continued to treat and produce water throughout the duration of the fire. Both plants had electrical power and produced water throughout the fire. In addition, there are no pumps, as it is fed by gravity. So just some more information on water there, which there was also a lot of information on that going on at the time too. As well as the communications, right? That's something that's kind of, we have to keep digging a little bit more to find out what's going on. So power, water, what did Maui Emergency Management Agency do? They've come under a lot of scrutiny. Everything is in here. Like all their web events, what did they actually do? Their public alerts, who did they deploy? Who signed the incident reports? All those things is all in here. So once again, have to kind of scroll a lot more through. But I want to stop and pause on this page. Crisis communications, describing the mayor, right? So I'm going to skip a lot of this here. He actually was at the EOC on August 7th, the night before. It was empty. He realized the shift was going to start at 9 p.m. He gets a text alert at 5 a.m. on the 8th, right, saying that evacuations are happening in Kula, the shelter's opening. And so he goes to the EOC at 6 a.m. And at that point, he only knows about the Kula fire. Remember, that's going to be 6:30 that the Lahaina fire AM starts. So he's in there. They report the Lahaina fire around 6:30. But while that fire is being monitored on Lahaina, everything was about Kula, given the larger size of the Kula fire and adjacent evacuation area at that time. So he goes to the Haima meeting at Zoom that morning. There was great concern about fires on a Big Island and in Kula at the time. The winds in Hawaii and Maui were steadily increasing, and air assets could not be used. They knew ahead of time that they were in for a battle. So later that morning, they told him the fire was contained. That was likely that 90% contained by 8 a.m. and then eventually by 2 p.m. declared all the way contained. And he doesn't report anything else until after that. So throughout the day on August 8th, until approximately 2:30 in the morning on the 9th, he stays at the Maui government complex in Kahului, moving between an EOC and his office. So he must be hearing reports from the Lahaina fire going on there, right? Nothing had lit up in Kula during this time. The mayor could still see the Kula fire burning from his building. And he thought that Ko'i High School was going to be lost at Kihei. He thought the high school was going to burn down. So you can try to get a little bit of his mindset when they're making these decisions. And here is what's really striking. Huh? Arriving at the EOC in the morning of August 9th, mayor is first made aware that lives were lost in Lahaina.
Crazy.
Later that day, I mean, it's, you know, honestly, the police didn't actually reach the first body until 8 a.m. this morning. So like they weren't counting bodies or worried about bodies yet either. So when they found the first body, they probably made the call in, and then that's when he found out too. But by that point, it was already, all 102 were already dead, right?
Yeah.
So a little bit more of how the mayor interacted at the EOC. He reported that his role was to ask questions, be supportive, and get resources, and not take over from the professional staffs at the EOC. Right. So ultimately, he's basically not deciding who gets resources, but working to get resources to who needs them. Right. And that's what's going on there. They note there was limited information coming in from other sources and, quote, nothing in real time. That's striking too, right there. The mayor and his staff start seeing information trickle in via social media, and also starting getting calls from the governor, Lieutenant Governor. Remember, the Governor Green is off island at the time. So Lieutenant Governor Luke who's on Oahu calling. Does not remember seeing any written flash reports or sit reps. Everything was verbal. There was, quote, no reliable communication other than public safety radio, he recalls. Nobody knew how bad it was. At one point, the room in the EOC got quiet, and you can tell something serious had happened. The fire chief reported, assistant fire chief reported they had not received communication from one of the fire crews. This was likely when the fire crew was issuing their mayday. The mayor does not remember how he found out about water rescues along Front Street. His main concern was getting them out of the water. They actually call the Coast Guard. The Coast Guard comes and pulls people out.
That was the next day.
That's later in the report. Yeah, it happened that day. So, yeah, it was hectic for sure, right? And so you can kind of see a little bit of the dynamics of the mayor. And I won't go into any more what the mayor was doing beside that little communication piece there, right? And when we had heard that he had not heard about how bad the fire was until we started hearing about it from social media, that's the details and more nuance of what that actually means, of how that actually played out here.
I still think that's pretty soft on the, you know, what happened. Like, oh, we saw reports on social media. Yeah, come on, guys. They were all over.
What the mayor was reporting that he did, right? So like that's how it's put forth here. And yeah, this whole report's just a timeline. Or like, here's just some facts we found. There's another report coming following this one with more stuff besides just here's our initial fact-finding mission results, which is really all this 200 pages really is. It's just a lot of information, right? And much for what the mayor said, he said what it was like for him, and that's all this actually is. Yeah, his viewpoint is not the only one for sure.
Yeah.
So, okay, moving on from that communication piece, timeline goes on. This is more of that communication, like what reports are they putting out? What's the AMR doing? Here's a Coast Guard, since you're curious about what happened with the Coast Guard there, right? The Coast Guard could not fly their aircraft. So they actually transport a rescue swimmer by ground to the harbor, right? And they recover one deceased female from the water. They rescue 17 people ranging from age 5 to 60 and assist 40 on shore. And so, and then after that rescue phase is done, then they come and park the Coast Guard cutter and the resource cutters to coordinate all the search and recovery efforts with all the Good Samaritan vessels all around there. So there was a 2-stage response there, but it was, no one knew who was doing what at the time. And here there's a little bit more information on that. So there's more here, ARFF, there's DOFA in here as well. Appendix has tons of information here as well, like, all the different, I can kind of just scan through, right? All the different products from Weather Service, all the different forms that were filled out and attached on here, from the emergency management. This was just like, let's just put everything on paper. It is redacted. What you notice is on here is that there are individual addresses are out. You'll see street names, or you'll see like things like that, but they try to protect people's privacy as well. So this is really all the comprehensive report, right? Released by the Attorney General, performed by FSRI on there. There's a little bit more that I can say. If you want to jump in, Danny, feel free, but otherwise I'll just add a little more that I found online.
I think you gave the summary. Yeah, I think you got the summary good. But yeah, if you want to show some more the stuff you found.
Yeah, this is, I don't go through tons of detail, right? But, the kinds of buildings were all assessed. The breakdown of needs came out after the fact. I like kind of scanning some of the articles of what have we learned, right? So we can go into that a little bit, even if it takes us a little long. This is an important topic for us. It's like the newest disaster of the state that's right up, our mission, aligns with our mission. It's not the big island, but it's super important to us to understand what went wrong so we can work to fix it, right? There was actually a fire in July upcountry Maui, and so there's an article from the Honolulu Civil Beat from July 16th that kind of talks about what things are like and what has actually changed since then. So I'm just scroll all the way down here to lessons learned. What's really changed. So what's changed, they say, is they're trying to create a unified command so that all agencies can actually communicate with each other. They noted, massive communications problems among agencies battling the wildfires. Examples included police and firefighter radios operating on separate channels, so they didn't know what the other agency was doing. Instead of the mayor getting direct reports, he was getting information from social media and calls with the lieutenant governor. And the emergency management director on Maui, who was on Oahu at the time, was not getting information from the EOC, but rather from his administrative assistant as well. So lots of pinch points there for that communication to get caught. So asked what's different about this time around with this new fire. The most obvious difference is we have a different team. We have a different set of skills running our EOC and directing that. So that's what the mayor said last month about this. And as far as lessons learned, we're still trying to improve throughout each event. And the specifics of that, the details of that, I'll leave to the experts. So he can't really say much more about it than that in the end. What about sirens? They were not used then. You only use them for tsunamis back then. They now say that approach changed. Officials will now sound sirens for wildfires when necessary. So that's the most recent report there. There are some other things as well, right? Here's a article. So there's some various insurance companies that are trying to, kind of put out information to also reduce future losses for themselves, right? So they note that there are similarities between Maui and the 2018 Camp Fire in California as well, right? Both had power grid issues potentially and vegetation issues there as well. So they note that there are things like, say that again?
The difference is that there was no getting a hold of the campfire that got Paradise. There was no containment at any point before the town got taken. Whereas this one...
Yeah, there was no AM fire, right?
Yeah.
Yeah.
Which is ultimately the same fire. It just rekindled.
Right. Yeah, so... Yeah, they do note those kind of issues, right? They do note that there are issues of just the kind of homes that were in the area. We talk about home hardening, right? A lot of the houses were old and had like old roofs and largely wood construction. These guys here had no intention of hardening their home against fire. They happened to replace an aged roof with heavy gauge metal, cut back their encroaching foliage from the sides of the house, and put in a 3+ foot perimeter of stones to preserve and modernize their house. And that's why they're the one house in the picture that looks untouched by all of this. So other factors like that as well, right? So that's the kind of houses that were there, the kind of preparations. That's one insurer. Here is, let's go to this one. Another insurer here as well. And says it's the evacuation plans and routes. It's the emergency alert systems and warnings, that communication aspect there. And it's also damaged or faulty transmission lines. Right? That's what they kind of put it down. They actually pull in the Tubbs fire as well. That was 12 miles from Calistoga, California, back in 2017, the year before. Right. So for some comparisons, the Lahaina losses are approaching $3 billion. $3 billion, 2,200 structures, and 2,200 acres. There are the stats on Lahaina. The Tubbs fire was more than 5,640 structures, $10 billion in loss, 22 deaths. So per capita, a lot lower fatality rate there. You go to the Camp Fire, 85 deaths, 18,800 structures destroyed, $16 billion in damages. Right, so that shows you the differences there. It was a lot smaller in the size and all that, but if you look at the fatalities, disproportionately high for the Lahaina fire. I think that's something that's worth mentioning as part of that tragedy. So,
do you have anything else? We've been going kind of long, and I think getting to that point, try and go through, sum up. We're going to lose our ASL team here shortly.
Okay, so yeah, on Hawaii Island, what's changed? Okay, what's changed is there's been a lot more focus on messaging here. The fire department is now upping its staffing and activating the EOC sooner. There are 30 more miles of fuel breaks around high fire zones, especially up north. There are community efforts going on, including Waikoloa Village, adding a new egress on Hulu Street. They're adding a third emergency road to Waikoloa as well, right? And they are building homes up there, and there's not enough exits yet, so they're trying to build the houses and put in a road hand in hand. And ultimately, it does come down to individual preparedness as well, where people have to decide, do I have somewhere defensible in my property that I could actually shelter in place? Do I need to leave? What's going on with that, right? So that's lessons on Hawaii Island. There are other lessons also taken on Oahu, on Kauai, and I won't go through those as well. One important thing that's noted in a lot of those insurance company reports is that prior to that Maui fire, there was no requirement and no institution of PSPS, which is Public Safety Power Shutoff. So since then, Hawaiian Electric has instituted PSPS, right? Which means that they're going to now preemptively cut off power to the lines in areas that are hazardous during these extremely hazardous conditions. The way this is going to work, 24 to 48 hours before a possible PSPS, they'll put out an alert. They'll actually say it's happening if it does happen in higher wildfire risk areas. Then they'll know when it actually is beginning to be restored, when the emergency is passed and they're turning things back on. And finally, when everything is supposed to be back on. So that's kind of how it's actually going to go. This is not island-wide. If we look at the maps of where this is happening, it's largely on the west sides of the islands. You see west side Oahu, west side Maui. Molokai is kind of in the center there. But Hawaii Island, you can look at that. We have areas up here on the northeast part of Mauna Kea, but otherwise it's Waikoloa to Kohala to North Kona. These are the areas that are the candidates for these PSPS outages.
No
right?
ocean, even though it is kind of dry, does not fit we're talking about really dry areas here.
And you have to have a lot of grass too, right? Like, if you have a lot of lava, that's kind of a natural fire break, that might be good for fire, right? At least. So this was what Hawaiian Electric has been doing, right? There's a whole financial settlement came out recently, so there seems like they're putting forth a lot of effort. I won't go into any of the legal stuff. One last thing though is that they have put out a big contract worth $14 million with Alert West out of California that is installing and sourcing cameras all over the place, combining artificial intelligence to then detect these possible conditions reviewed by people to make sure there are real signals. And then if something is real, it's reported to authorities, hopefully faster than you would have gotten it otherwise. Here's what some of these cameras might actually look like. You see how they're attaching it to the power pole right there. And it's got a weather station as well as a camera on here. I think this is, or maybe this is just a weather station. This is just weather station. The cameras are elsewhere. And what this looks like is this. There is you can go to alertwest.info and get to this map. And so what this is showing is sets of cameras across all of the Hawaiian Islands. And they're all different ones here. You can kind of pan over them and they'll get highlighted over here on the left side of the map. So for example, let's focus on Hawaii Island, just to kind of zoom in a little bit. And let's go to Waimea, for example. And now I can see these are the 4 cameras and the directions that they are looking off here, right? Northeast, southeast, west, and northwest there. And any one of these, you could then come into and say, okay, I see something on this image. I want to say, what's going on right over here? Is that a fire? It's probably a reflection of the sunset on someone's window or something, right? But I'm curious where that is. I can put my mouse right over here, and you can see on the right side where that red line corresponds to where am I looking for ground truth, right? Something like that. So this is part of a big system I'm going to show you this is all Hawaii Island. What you can also do is, for example, click on this active cameras up here. It's going to filter out all these yellow ones and leave only the blue ones, which are the ones where the AI says, I'm not sure what's happening here. Maybe you could check that for me. Well, actually, those disappeared from Maui. So what I'll do to show you guys this is I'll zoom out even further, because let's click all again. I'm going to show you where these cameras are situated all over the country and even into Alaska as well. So you see all Hawaii, Western US. You see some over here, and it might be Newfoundland, or is it? I'm not sure. Maine as well, Maine, and then Alaska all the way up here too. So to give you an example of this, let's click the active cameras, because there are wildfires happening now. There's not in Hawaii, and there you go. Let's see what we see here. Right? There's camera showing fire over there. And this is in Oregon, Northern California in this case, Northern California. So some in Oregon too. Here's one. Macaulay Mountain. So that's how the system basically works. And so those are all the other, those are the current add-ons from Hawaiian Electric and from there in a bit. So that is a lot. Yeah, I think we can just add that on our end. We're also working on communications, right? We're trying to work with our own civil defense and improve these alerts to make sure that they're reaching people, right? If you look at all the recommendations that are given, they say to improve communication, make sure that it is heard put out on the radio more often or on TV more often, and often they leave out social media, right? Even though they suggest that the mayor was actually learning stuff from social media, still that's not quite folded in. So that's where we come into it. We try to fold in social media into disaster response, make it a two-way street of communication, so that it's not just coming from authorities going down to the communities, but communities can report problems back up to the authorities, have infrastructure in place ahead of time. We work with resilience hubs to make sure that there are places that can activate ahead of time to be available in case there are power and communication outages. Residents can go there to find those resources, right? And ultimately, we're going to keep that work going forward. And that's what we talk about all the rest of our time when we do our fundraising, is all of that. So we won't go into any more of that here. Okay, Dan. So yeah, I know I went a long time, but you know, I think it's an important topic for us to revisit. We put it off for a whole year, really, because it's really still kind of raw.
And I'm sure we'll come back to it. I don't know. There's a lot that got covered right there. Like,
yeah,
going over a whole bunch of different things. So, but each one of those segments could deserve far more talk than we gave.
Yeah, what I really wanted to do is, you know, when I was looking at these reports, I was like, wow, there's a lot more solid information. They've really compiled all the information. We can have an idea of what actually happened, what didn't happen now. And now it's up to us to actually look through the facts rather than live in the hangover of like all that bad information that was coming out and the fear mongering and let's stop it there.
I'll be interested to read the final report type of thing, because I remember in 2018 we didn't get a final report like that, but there was a lot of, oh, we did fine, it wasn't that bad, we did good actually. And I'm like, this was one of those disasters like you can't hide, but I have a weird suspicion that it's going to happen anyways. And they'll be like, oh, yeah, we'll see. I'm waiting for the final report where it's not just like, this is what the mayor said happened, and we're just going to put that without questioning it. Right? Like,
I'm not really sure what the order of reports is, right? This is like the timeline. They say that there's going to be at least one other thing coming out, but I haven't found out if there's more, what kind of sequence there is to that, right?
Right.
But just this is already huge, man. Just having it all out there, because we know how quickly that those details vanish and how quickly they like seep into the ground and into the ether of social media where you can't find it anymore. That's a real challenge. So
definitely had some real money to throw into making those reports, because those things don't just configure themselves and assemble overnight because you want them to. It's a lot of research, a lot of time, a lot of people involved in those papers.
Yeah, so
all right,
we'll leave Lahaina there for today. Is there anything you want to bring up from chat to discuss, or are we too far over
not
here?
Especially.
Yeah,
All right.
Luke shared some of the stuff, so if people want to check out these things, they can find them in the chat. They're on Google as well. Yeah.
All right. Well, so then if there's nothing else from our chat, thank you guys for sticking with us and sharing this Lahaina recap. And thanks, Lou, for your help in the back end. And we'll be back next week at our usual time, 5 p.m. Hawaiian time, unless something happens first. The situation is dynamic. You know, things could pop out. As far as, could flare up, I should say, not pop out. It could flare up at any moment. So we'll just wait and see. And I think that's going to be the prognosis for many months to come, possibly for longer than that. We'll be on our toes a lot. So let's see what happens.
Potential for an earthquake is there, as always.
Yeah.
But for a decent one, potentially.
Each one of these events that occurs teaches us a little bit more about how it's developing underground in Kilauea, and so it's interesting that way. There's been all kinds of funky stuff happen in the past. I'll get into all that maybe next week. All the different things that can happen and variations and all of that. But for now, we can just wait and see, and what happens will reveal something about the volcano. And we'll keep moving onwards, educating ourselves, getting ready for the next eruption that impacts people. Right, that's what we're doing here.
Yep.
So, mahalo everybody for your support. Until next week, we're the nonprofit Hawaiian Volcano Education and Resilience Institute. Right, we're trying to improve disaster preparedness and recovery for all of our communities here on the island and beyond as well. So, until next week, I am Philip Ong, Dean DuPont. Aloha, everybody. Push the right button here. I almost got the wrong one. Okay, one more time. Here we go. Aloha.